In lesson 15 of module 1, we're going to continue our work with tape diagrams as a way to model multiplication. And we're going to connect that to the work we did with arrays when we talked about the commutative property. So we're going to see how we can use tape diagrams to show commutativity, just like we did with arrays. Let's get started and take a look at our whiteboard, see how that can work. So you're going to get a couple of kind of problems in this problem set and in the homework. And I want to walk you through a couple of examples to make sure that we have a good understanding. First, let's review what the commutative property of multiplication says. And it's this, it's that we can have, we'll do a 4 by 2 here. And we'll say that's 4 times 2 equals 8. And then we know the turnaround of that fact is also true. I'll do it in a different color. We know that 2 times 4 also equals 8, and that could have its own array. It would be if we switched or flipped this array on its side, and that would look like this, 2 rows of 4. So that's the commutative property. And we can use that with tape diagrams as well. So let's show what that would look like with these same facts. So I'll do them in the same color. So 4 times 2 is showing 4 groups of 2. So I would have a tape diagram that shows 4 groups with 2 in each. So let's take a look at that. Split it in the middle first, and then split each of my 2 halves in half again. And my unit size for each is going to be 2. And the total is 8. So I've now showed, I could draw things in here. I could show that there's 2 in each of those, but I don't have to because I've labeled it up top that each unit is worth 2. 2, 4, 6, 8. So I've showed that one way. I could also show it this way. So another tape diagram, which I'm going to split into 2 parts this time because in this problem, I have 2 rows or 2 groups. And when I do that, that means I have 4 in each. And my total is still 8 because I would group count by 4s. And I go 4, 8. I could again draw things in 1, 2, 3, 4, 1, 2, 3, 4. I could have 8 things in there if I needed to for that visual representation. But again, it's not necessary because just labeling the first box on the left there is enough to show what the unit size is. So this is how we show commutativity with the tape diagram model. And it's very similar to the work that we did with arrays. We're just using a different picture or different pictorial model to show that work now. And so you're going to see on the problem set, and again, the homework, the front side of those is problems like this, where they give you a math fact, a multiplication fact, and they ask you to sort of do a tape diagram for both ways. So you do the turnaround fact and you do both tape diagrams, and you draw an array for both as well. So you might see something just like this on both of those. And there's sort of increasing level of complexity with each of them. In the first one, they usually give a lot of support, and that they'll tell you like 4 times 2 equals, and they'll leave the 8 blank. And the next one, they might say blank times 2 equals blank, and you have to figure all that stuff out on your own. So each of those will get a little bit more complicated. And then you'll also see things on your problem set and homework like this, where you're given a fact, I don't know, say 4 times 3 equals 3 times 4. And we could show with an array that that's true. We've done that before. We draw the array for both and show that they're just rotated. But you also can do it with tape diagrams. And so it would tell you to draw 2 tape diagrams, and you would. I'm going to draw them the same size, about the same size. There we go. Because the answer is the same, so I want to show that they like end at the same spot. They're the same size. And the first one is going to have 4 groups of 3. So I have to have 4 units in here. And I would say that each one is worth 3. I didn't leave myself much room down here. So this is probably going to get a little messy, but the total there is 12. You know, I'll move my bottom one down. Give myself a little more room here. Mr. Brunel wasn't planning too well here when I started this problem. And then the next one has 3 groups of 4, so that's going to look slightly different. Now I have 3 units, and each has 4 things in it. And if you count by 4s 3 times, you get a total of 12. So notice our result was the same. Both of these came out to 12, and we've showed 2 different ways to draw the tape diagram. Now, there's one important thing that we should talk about before we sort of wrap up lesson 15, and that is the fact that you can't just rotate a tape diagram like you can an array. So again, let's go back to that 4 times 2 that we did in the beginning. So I could have, you know what? No, we'll do 4 times 3 because I haven't showed you that array yet. 4 times 3. So 4 rows of 3. So we could then turn that into 3 rows of 4 just by rotating it on its side. And these things we know are in fact equal to each other, right? We've just rotated it. But let's look at what happens when we try to do that with a tape diagram. It doesn't work out so well for us. We'll talk about why here in a minute. So I could have this tape diagram, a similar one or same one that I just drew a minute ago. I have 4 groups of 3. Let me repeat that here. And each group has 3 in it, and I have a total of 12. So you might be saying, well, Mr. Brunel, if we can rotate arrays, why can't we just rotate tape diagrams? And this is why we can't do that. Because if I rotate it outside, this is what I end up with. My same size rectangle that's now been put on its side, but I haven't changed the number of groups or the size of the group. I still have groups of 3, and I still have 4 groups, and they still all add up to 12, or multiply to 12 rather. But you'll notice there's 4 groups here, and there's 4 groups here. Whereas in the array, there are 4 groups here, 1, 2, 3, 4, and there are 3 groups here. So just rotating the tape diagram doesn't change the number of groups or the size of the groups. In order to do that, you have to draw a whole new tape diagram. And in this case, it would again be that 3 times 4. Do that in here, a third color. Be that 3 times 4, where we have 2 lines here segmenting this into 3 groups. And there's 4 in each group. So again, we can't do this one, draw a big X through it, because that doesn't change the size of the groups or the number of groups. What we need to do is actually draw a second tape diagram. So that in that way, our work is a little bit different than what we did with arrays, and that we have to draw 2 of them, because one tape diagram can't represent 2 multiplication facts. And instead, you need 2 different multiplication facts related because they are turnaround facts of each other, but 2 different ones to be represented by 2 different tape diagrams. I know that that's a little bit confusing. We'll talk a lot more about that, but I did want to note it that it's not just as simple as when we worked with arrays where you could just flip it on its side, because I can see that I know from experience that that's something that 3rd graders will try. And I wanted to give you a heads up that while it's a really creative idea and it shows really awesome connections to some of the work that we did before, it is a little bit more complicated than that. And we do need to change the size of the groups and the number of groups when we do our turnaround fact. And by doing that, we need to draw a separate tape diagram. Again, I know that's a lot of language. I know it's a little bit confusing. I promise we'll continue to go over it. And I promise that it will make more sense the more times we go over it. Again, always ask questions if you have them. I'm always happy to answer them. You guys, again, are doing a wonderful job, and keep up the hard work.